The very first thing I did when I started thinking about this problem was I began sketching diagrams and labeling them. There's a lot of information in the problem, but once I had the diagrams, it was a lot easier to deal with. So the first thing I have is a bucket, and it's a right circular cylinder. I have a height of 12, and I have a radius, not a diameter, which is good. And the radius is 6 inches. So when I substituted that information into the formula, I had pi times 6 squared times 12. 6 squared is 6 times 6, not 6 times 2. That's 36 times 12, 432 pi. Leave it in terms of pi. Believe me, it'll be helpful. Do not multiply by 3.14 or anything else. That's my bucket. Now let's think about this so-called shovel. I don't know about you, but most shovels I've seen are not in the shape of a cone, but that's what they told us to do. So there's my cone, and my height is 4, the radius is 3, so 1/3 pi radius squared, that's 3 squared times the height of 4. So 1/3 times pi times 9 times 4. And I'm going to not worry about the pi for the moment. 1/3 times 9 times 4 is 36, so that gives me 12 times pi. Now this is where the magic comes in. We're being asked to figure out how many shovelfuls of water we need. So we're going to take the whole bucket, that was the 432 pi, and we're going to divide it by each shovelful, which is 12 pi. And when we do that, I promised you that the pi's would take care of themselves. Those pi's are going to actually cancel out. And you're going to take, because pi over pi is 1, just like anything over itself except 0 over 0 is also 1. So 432 divided by 12 is 36. What does that mean? It's going to take 36 of these so-called cone-shaped shovelfuls. It's going to take 36 of these shovelfuls of water to fill that bucket.